Hello. In this video, I'm going to be explaining problem 3 from the 2016 F equals MA contest. In this problem, we have a student dropping a textbook into a deep layer of snow, and we are given the height above the snow, the depth to which the book sinks into the snow, and we are also given the mass of the book. And we're asked to calculate the force that the snow exerts on the book, assuming that the snow exerts a constant force. So let us draw a quick setup. So here we have a book, and we're told that it's 5 kilograms, and it drops some height, H1, and that's 3 meters. And then here is the snow, and it sort of goes down into the snow, and we have H2, and that's 1 meter into the snow, and then it comes to a stop right here. So here, the book is at rest, and here, the book is also at rest. So, since the problem gives us asks us for the force, and it gives us all the necessary distances, it makes sense that this would be a problem about work. And more specifically, we can use the work-energy theorem, which states that the total work done on an object is equal to the change in kinetic energy. This is very nice. And it plays with exactly what we want, because the book starts at rest and ends at rest, so the change in kinetic energy is actually 0, because the book both starts and ends with 0 kinetic energy. With 0 kinetic energy. And so all we need to do, and that means that the total work is just 0. So now, let us calculate the total work. So there are 2 components of the work. The first is the work done by gravity. And how much does that equal? It equals the force of gravity, so that's mg, times the height that the book, the change in height of the book. And that is equal to h1 plus h2. This is something that you should be very careful about. It may be tempting to think that the book falls through a height of h1, but remember that even when the book falls through the snow, it is going downward, and so gravity will continue to act on the book and will continue to do work on the book even when the book is in the snow. This is a potentially easy mistake to make, and I know because actually I did make this mistake when I took this test back in 2016. So be careful about this, that the change in height is h1 plus h2. The total distance that the book falls through the air and through the snow, and not just through the air. And now what is the work done by the snow? It is equal to negative. Now it's negative because the force from the snow is acting in the opposite of the direction of the motion. So if we look back at the diagram, the force acting from gravity acts in the direction of motion, whereas the force from the snow will actually act upward to stop the book's downward descent, and it will actually act opposite the direction of the motion, so the work done will be negative. So it's negative, and now it'll be the force from the snow multiplied by the distance that the book travels through the snow, which is just h2. And so now, since the total work is 0, we have mg times h1 plus h2 minus fsh2 equals 0. So fs is just equal to mg times h1 plus h2 over h2. And so this is a very simple expression. Now all we need to do is plug in the values. So m, we're given as 5 kilograms. G, the convention in F equals MA is to do is G equals 10 in SI units. And then h1 plus h2, h1 plus h2 is 4 meters, h2 is just 1 meter, and so ultimately we get that the total is 200 newtons. And so now, if we go back to our options, we see that the answer is E, 200 newtons. All right, and that's basically all there is to this problem. So thank you for watching, and I hope that was helpful.